second order derivative. What is second order derivative? We have seen that if our function is fx, when we take first order derivative, we call it as f dash x or say y dash. There are so many representation for this. But when we divide, this differentiation is actually the division of a curve in smaller part. So when we again divide it, they're making it more smaller. We are trying, or you can say that we are trying to make it more smaller so that we can get the slope. This dy by dx is nothing but slope. But after getting the slope, which direction this slope is, whether this is increasing or decreasing, this can be easily found out by double derivation. So dy by dx of y is dy by dx, then again dy by dx of this result, that is dy by dx of fx, which is called as f double dash x. Okay, so this is dy by dx is f dash x and dy by dx of dy by dx is f double dash x. This is called the second order derivative. We write it as d2y by dx2. So second order derivative of fx is nothing but f double dash x. It is denoted by d2y. You can also write it like y double dash. Okay, one more representation is there, y2. Find d2y by dx2 if y is this. So y is this, dy by dx is what? This will be 3xy, this will be sec square x. Now we have to differentiate it again. Let us take this 3 out. X square, differential of x square is 2x. So you get 2x. So 2 into 3, that is 6x. Sec square x, that will be 2 sec x, and sec x is sec x tan x. So this you get. If y is this, then prove that d2y by dx2 plus y is equal to 0. So what we are going to do here, dy by dx we can find. This will be a sin theta is cos theta, b cos theta is minus sin theta. This will be dy by dx. And d2y by dx2 will be what? Again, let us differentiate this. So this will be a cos theta is minus sin theta, and this will be b sin theta is cos theta. So this is actually equal to minus y, because this is y. If you take minus out, it will be minus y. So now take this minus y here, d2y by dx2 plus y is equal to 0. If y is this, then you have to prove that this is the equation. So what we will do here is, we'll find this, and we'll put it in this equation. So dy by dx is what? This is 3 e to the power 2x, so 3 will come here. Then e to the power 2x is e to the power 2x, and then 2x is 2. So it will be 3 into 2 is 6. This way, this will be also 6 e to the power 3x. Take 6 out. d2y by dx2 is what? Differential of this again. Differential of this again will, you can take 6 out, and this is nothing but very simple, because e to the power x, d by dx of e to the power x is e to the power x only. That is why these things have become simple. Now we have found these two. Place it in this. Place it here. So you get this. This is the final result. Y is equal to sin inverse x. Show that this is equal to 0. So sin inverse x, the dy by dx of sin inverse x is 1 by under root 1 minus x square. Take this under root 1 minus square here. And now differentiate this. When you differentiate this, you can differentiate it using what rule? Leibniz rule. That is, first take this out, d2y by dx2, then take this out, d2y by dx2, this one. And when you rearrange it, you see that it becomes actually equal to what is being sought. We can also do it alternatively. Y is equal to sin inverse x. So what we have here is y1, that is the differential of y. First is 1 by under root 1 minus x square. So take 1 minus x square here and square both the sides. Now again perform the differential. The differential of y1 just represent it as y2. d by dx of y1 will be y2. So when you differentiate it again using what rule? Leibniz rule. You get this equation which is